So you've been working with geometry for the last day. I don't know, some of you, that might be your worst nightmare is going back to geometry, but it's just all area and trapezoids and rectangles and circles and things. We're going to keep pushing forward with geometry, but we got to cover the problem of what do we do if it's not a recognizable shape, right? Okay, if it's not a circle, if it's not a semicircle, if it's not a quarter circle, if it's not a perfect sine or cosine, if it's not a nice trapezoid or rectangle or triangle. So sometimes there just isn't an easy way to do it with geometry, right? So we need a different way. And so we're going to learn how to use our calculator to find those times when we can't do it with geometry. So please have your calculator standing by in radian mode. So remember that we defined area as being this integral, okay? That is the perfect value of area. So one way that we've been working with that is to do it with geometry. We started with the RAM techniques. We did L and R and then MRAM, and then we added the trap technique. And then we added doing triangles and semicircles and sine and cosine. If none of that works, our second method is to use Math 9. Now Math 8 is what we used in derivative calculus. Math 9 is now what we're going to use in integral calculus. And so you'll have that, we'll be working on that together. And so we want to look at the integral starting from -1 to 2 of x sine x dx. Okay, so make sure your calculator is in radian mode, and would you please graph the shape of this? Okay, so x sine x, and then make sure you set your window, as long as you're in radian mode, set your window to go from -1 to 2. And your y's, you know, they can be probably -5 to 5 would be fine for your y's. And then take a look at what you get. Okay, so hopefully you've had a chance to graph that a little bit. And so what we see when we graph that, when we are going from -1 to 2, is you're going to see a part of a graph come down, hit the origin here, and then go up and increase like that. So why is Math 9 the best option here? Okay, well, it's because of this x. This is not a regular sine x. If it was a regular sine x, we could totally do this. But it's not a regular sine x, and not only is it not a regular sine x, but we also have bounds that aren't nice in radian mode, right? Our bounds are -2 and -1, which are not nice like 0 and 2 pi or pi halves. So we want Math 9. All right, so what I want you to do is go to a clear home screen, and I want you to put in Math 9. And I'm going to switch to my video camera so I can show you how to do this. All right, so Math, and then we're going to go down to option number 9, which is FNINT, which stands for function integral. So go ahead and select that, and you should have a nice integral pop up like this. If you don't, okay, if you still have FNINT that is in a, like it's just words and it's not a symbol, I'll grab you have an older calculator, and I'll have to grab that and show you how to do that. But if you've got this one, it's nice and easy because you just put in -1 for your lower bound, and then an arrow to put 2 in for your upper bound, and then put in x sine x with a parentheses after the x, and then go to the end and put x to show that we're doing this to the x-axis, and then hit enter. And boom, calculator gives you your answer of 2.0427, which we're going to round to 2.043. And that would be the value of the area under this integral. All right, now I'm going to switch and show you how to do it with the older version of the calculator. So it's still on a home screen. Just make sure you're in radian mode. Okay, double check that. And then go to Math number 9 again. And then you're going to have words that say FNINT. Okay, and you do things in a little slightly different order. You need to put the function first, which is x sine x. So go ahead and type x sine x parentheses. And then you want a comma. The comma is right above the number 7, okay, that button right there, so comma. And then you need to say what axis you're working on. So x would come next to represent the axis, followed by another comma. And then you're going to put in your two bounds. And your two bounds are -1 and then a 2. Let's see here. All right, -1, comma, 2. Sorry, I messed up on the first one, so ignore the first line. So make sure you put your function first, comma, x to represent the x-axis, and then -1 and 2 are your bounds. And then you put enter, and you get 2.0427, so 2.043 as well. All right, so what that means overall is that, hang on, there we go. The area that we're looking at under this curve and above the x-axis, that area turned out to be 2.043 square units in terms of area. Okay, let's try another one. Find the integral of 2 minus x squared from 0 to 4. All right, 2 minus x squared is a parabola that dips down beneath the x-axis. All right, so coming this way and then. So we have part of our area that is above and part of our area that's below. And we're going to let the calculator take care of all of that. Okay, the positive area here and the negative area here. And depending on which area is more, if there's more positive area, our answer will be positive. If there's more negative area, our answer will be negative. But why is Math 9 good here? Math 9 is good because this doesn't fit into a triangle or a rectangle. This is not a semicircle. Okay, it's a parabola. So we want to use our Math 9 for that. So first you have to write down an integral. If there isn't an integral already written, you have to write it, okay? That's part of the requirements. You get to use your calculator, but you have to write the integral. So we're going to do an integral going from 0 to 4. So on our graph, that would be from 0 to 4. And then in parentheses, we put 2 minus x squared, and that function must always go in parentheses on your calculator and on paper, and then dx. And then we'll do a Math 9 again to evaluate this because it's not a perfect situation for geometry. All right, we'll bring out our graphing calculator again to use our Math 9. And so we'll do Math 9 from 0 to 4. And then we're going to put in the parentheses 2 minus x squared. So it's nice the calculator puts the parentheses there for you, but on paper you've got to add it yourself. And then x at the end to represent the x-axis. And we get a negative number. That means there's more negative area than positive area. So there was the space underneath the x-axis was bigger than the area above. Okay, so then we put that this is approximately equal to negative 13.3 repeating, and that's again square units as it represents the area under the curve. Okay, let's try another one. Here's a natural log this time. So 5 plus a natural log. So let's look at the visual on that. A natural log is a lazy function. Its graph kind of starts out good but peters out. So this graph starts out and then it just sort of loses steam as it moves out that way. But we're going from 1 to 5. And so 1 here, 2, 3, 4, and 5. And all of this is above the x-axis, so we expect our area to turn out to be positive. That's our expectation, the answer. All right, so we have to draw the integral here. So the integral would be on bounds 1 to 5, parentheses, 5 plus ln x, and then above the x-axis. So we'll do a Math 9 on that as well. Okay, so Math 9, 1 to 5 of 5 plus the natural log of x. Okay, end your parentheses, but you still have the major parentheses around that, and then dx at the end. 24.047. All right, so approximately equal to 24.047 square units. And again, we expected that to be positive because it was above the x-axis. So Math 9 is super helpful in finding the exact area when geometry doesn't work. Math 9 is also helpful in helping us switch between our units. So we already know that we can use Math 8 when we want to go down in units. So if we want to go add time, we do a derivative and we do Math 8. But if we want to go upwards between our units, and we want to go from meters per second squared to just meters per second, that's the Math 9, that's an integral. And if we want to go from meters per second to meters, that's another Math 9, that is an integral. So an integral can, the Math 9 can be useful for that as well. So this is called an accumulation. When we want to change and have an accumulated effect, we are going to use an integration. So if you want to find a cumulative total, then you're going to use an integral. So here we go. Water is pumped into a tank at a rate modeled by W of T equals 20 gallons per minute. Okay, here's the clue, 20 gallons per minute for 3.5 hours. Find the accumulated total from the time 0 to 3.5. So we want to go from gallons per minute and we want to go to just gallons. That's the total. And so we're going to use an integral in Math 9 to do that. So you have to draw, you have to write the integral down. The integral is going to start at time 0 and go to time 3.5. In parentheses is going to be the number 20 because that is the rate that had the units of gallons per minute on it. And then we want d, and now this time our variable is t. Okay, see this is time t, so this would be dt. So we want 20, we want the integral from 0 to 3.5 of 20 dt. And then you're going to use your Math 9 again. Now Math 9 has to be the variable, only variable you can use is x. So that's fine. Your calculator, just put x in is fine. When you write the integral, I want t down, but this turns out to be 70. And then we've got gallons as the units on that. So again, just make sure you put t for your time interval when you're doing a word problem. This is a problem in motion, so time is the variable. But when you do your calculator, just use x because your calculator doesn't know the difference between t and x. Okay? All right, so hope you have a good experience working with Math 9. Really enjoy your day off, and then I'll see you refreshed and ready to go for 3 weeks until we have our spring break. All right, so I'll see you on Monday. Bye.